I'm a software consultant. I help people to write quality code, or I tell people how to write quality code and then go away. I'm a big fan of things like test-driven development, behavior-driven development, obviously Symfony. So these are all the things I'm helping people with. This topic is lightning fast Symfony tests. So how long does it run to run your test suite? I wanted to ask you that question, but I can't see you, so that's kind of pointless. If you raise your hands, I won't see them. I often help companies with test suites that run for hours. Even parallelized doesn't help much. And this talk is caused by those kinds of problems. I've been writing those kinds of tests myself a few years back as well. So for the purpose of this talk, I'll classify the tests for two groups. We've got integration tests and unit tests. Integration is everything that executes more than a single behavior, goes through multiple behaviors, while unit tests is something that tests a unit of code in isolation, one behavior at a time. So integration tests might be UI tests, might be service tests, acceptance tests, all of those tests that go and execute multiple layers of the application. And the standard scenario, the worst case scenario is we've got some kind of a WebDriver test or something that goes end to end and executes things like Selenium. Selenium then goes to your web server. Reaches Symfony, executes Symfony, then your code that you actually wrote that you want to test might connect to the database, to some external APIs, whatever. That's pretty complex stack. At any point of this flow, something might go wrong. And even if you go through Selenium or Phantom.js or tools like that, you try to go even a bit more low level. Start here with some kind of a good test. Call the web server directly. Still, there's quite a lot of things that execute. You might try a web test case from Symfony and avoid HTTP requests there. Call Symfony kernel directly, process the request. That's still slow. Even if you go to your services directly and try to interact with that, still hitting the database or the APIs, that's still slow. And even if you try to do some tricks with mocking the database or trying to replace it with a more performant one, in-memory database like SQLite or mock your APIs, that's still not fast enough. It usually starts simple, and you think, you learn tools like Mink or Behat and start writing your end-to-end tests, and that's you're so impressed that it works. And it's so easy to do. It's so easy to implement. Some tests can even be written by non-developers. But after a few weeks, few months, you notice suddenly it's not so nice anymore, because the tests simply, you can't run them on a single machine. Okay, it takes too long to run them. To make you realize how complex the problem might be, here's a little exercise. Count how many execution paths there is in this piece of code. Got three conditions, three if statements. First one, there's two. In the first block, there's two paths. Okay, either the service A is enabled, returns true or false. Then we execute the inside of the if statement or the else statement, right? The second one, that's only one if, but with two conditions in there. So that's four paths in that second block. Okay, the first part might return true, the second might return false. First might return false, second might return true, both might return true, and both might return false. Okay, and if you actually count the total number of paths for this block of code, there's 8 distinct scenarios that you have to account for, you have to write tests for. And that's fine. Unit tests can deal with this perfectly fine. But that starts a bit more complex if you try to write end-to-end tests and cover those scenarios. Okay, let's jump a level up. Let's say controller, there's 4 paths in the controller. It calls some repository. There's 2 paths there. Calls another service, and that service calls another service. Okay. If you try to test it end-to-end, you get like 80, potentially, it not necessarily depends on the code, but potentially 80 paths to account for. If you do it end-to-end, that's quite a lot. And not the number is an issue here. The issue is that you can't possibly do that. You can't think of all those cases in such a wide context, in the context of that many collaborators. Okay, so you might cover it something between 1 to 80%. And the worst part is you will never know where you are, whether you're closer to 1% or closer to 80%. It gets even worse if you try to refactor this. Let's say service A does too much, let's split it. Execution paths don't change, we have the same number of execution paths, just extract a piece of that code into another one. Okay, we have more moving parts, it gets more complex. And these kind of tests are not only slow because the execution is slow or just so complex. They're slow because the feedback is poor. So they slow you down when developing, when working, when fixing bugs. Okay, if you get an error like this, expected 400 status code that got 500, you need to go down there to a lower level and debug that. Okay, this doesn't tell you anything of what's wrong. Where a unit test will tell you exactly where the problem is, which class, which method, which lane of code. Okay. Here you have to, if your unit tests are passing, but a functional or integration test is failing, then you're missing a unit test. Okay. Another thing is reliability. If you ever used things like Selenium, you know it only takes more time and more time to maintain those test suites, right? Famous element not visible on the page. Okay. If you're new to that, you start adding sleep statements. I need to wait for that element to appear, and then I can click it. It slows down the whole suite because you wait on every page load. If you're a bit smarter, you try to find some elements on the page and only wait enough time for that element to appear. But still, that's a bit flaky. Start spending time on the things you shouldn't be doing. You start spending time on making sure that your tests somehow work and don't break in random moments. That's just a waste of time. That's not what you should be working on. So, the kind of solution for that is, like, it was presented by Mike Cohn in his Succeeding with Agile book. The test pyramid. It suggests how much testing you should do on those three main levels. So the foundation of your test suite should be unit tests. Even 70% of all your test suite should be unit tests. It's a good foundation. Then you might have some service integration tests. Everything above unit is an integration test, actually. And some UI, just to see if everything is wired up together properly. Well, what happens most of the time is people do it like this. It's an inverted test pyramid. Okay, they have some unit tests, maybe some service tests. Most of it goes through the UI. And sometimes they are the cream on top. And that's called testing ice cream cone. So I'm not going to sell you some silver bullets here. It's not about tools. I guess the main thing in stock, it's not about tools. It doesn't matter if you use PHP unit, PHP spec, bhat, doesn't matter. They're all performant tools. It's not what slows you down. A few months back I worked on a project where they decided to replace, fitness with bhat. Because someone did tests and said, okay, bhat is so much quicker than fitness. It was quicker because there was only a few tests in there. they decided to move to Behat, and a few weeks later, instead of 3 minutes, the test suite was taking 10 minutes. And now it takes, I don't really know, but probably an hour. I left the project. So the tools won't solve your problems. The approach will. So, and the speed here is not the only issue, because you could actually take the whole test suite, partition it, run each test separately in parallel. If you have infrastructure, you could do that. And the whole test suite would take you as long as the slowest test. Right? But it wouldn't show you where the problems are if tests are failing. It still wouldn't be reliable. I'm not saying that integration tests or end-to-end tests are useless. There's some value in that. Particularly, unit tests are isolated, so you can't really simulate user journeys with them. You can say, okay, if I go there and do that, then something else should happen. That's what you have acceptance tests for, or end-to-end tests for, functional tests for. So you will need some, as on the test pyramid, you'll need some amount of those end-to-end tests still. But the focus should be on unit tests. And I wanted to go through an example with you. We'll have a look at implementing a price calculator. Price calculator that is supposed to fetch a product from the database and then calculate its price for a given currency. So the price is stored in a certain currency, and we need to convert it to the one that user requests, such a small microservice. That currency converter is provided by a third-party API. So the obvious implementation. We've got a price calculator class, and it's going to use Doctrine Entity Manager to fetch the repository, fetch the product, and we'll use Guzzle to make that connection to the external third-party API. Right, everything is injected into the constructor. We've got a price method that for the given product UUID and the target currency should calculate the price. And the whole implementation is a single method. We fetch the repository from Doctrine, try to find the product by ID. Obviously, it might not be there in the database, so we need to throw an exception if it's not found. There's an additional requirement I didn't tell you about, but if the product is out of stock, we shouldn't calculate the price. So we throw an exception again. And also, we pay for that API, so we don't want to make too many requests. We also want to make it a bit more performant. So we don't want to connect to that API when it's not needed. So if the currency that we want to convert to is the actual currency of the product price, then we just return it. And then some complex Guzzle stuff just to make that call with proper parameters. So imagine, if you wanted to test it, you need to test it end to end. You would need to actually populate the database with a product, 3 variations of a product. One that's, what doesn't exist, that's easy. One that's out of stock, one that has a current currency the same that we asked for. And you would need to populate the database. The code will need to fetch that from the database, then make that actual HTTP connection to the third-party API. Pretty slow and not really reliable. You might say, hey, let's mock the repository. But the repository is not something we own. That's not our thing. We don't control that. Even if it's an interface, we don't control the interface. So yes, we might mock it, we might stub it. But the assumptions we would make, even if they were true at the time, there's no way of verifying them that they didn't change after a while. So Doctrine releases a new version, and they might break something. We wouldn't know because we stopped their interface. So there's an expression in unit testing: don't mock what you don't know. Okay, there's a reason. So let's think this is how it looks like. So we have no unit tests, everything needs to be tested on the integration level, and that connects to the outside world, to the database, and through the wire. So if you want to stub or mock stuff, we need to own those interfaces. So let's introduce interfaces. Let's introduce the product repository interface that accepts a string UUID and returns a product. It might throw an exception if the product isn't found. And then we also have a currency converter that, for a given price and the currency, returns, actually it should return a price. There's a typo there. That lets us properly unit test this, because we can suddenly stop our dependencies, our collaborators. Tests should be isolated, that's why we stop them. We don't want a bug in the repository influence the test of the price calculator. So a simple test that the price is converted to the target currency. We just set up some basic value objects or entities. So we've got a price with a given currency. We create a test product, which is just some test implementation of the product to make the test more readable. And we say, okay, for this product, the expected price would be this. And then we stub our collaborators, so product repository first. And we say, each time you ask for this UUID, return this product. Okay, familiar with test doubles? So this way we replace the actual implementation with a fake implementation. And we say, we kind of program responses. These are stubs. And we also say, whenever you call a currency converter with this price in currency, return the price, expected price. The thing I used here for, this is a PHP unit test, but what I used for stubbing is called Prophecy. It's available in the latest PHP unit versions. It's a mocking framework from PHP spec, which makes your mocks a bit concise, mock definitions a bit concise, a bit more concise than PHP units ones at least. And then we create the class we're testing and call the method under test with certain arguments and assert that the price is the price we actually stubbed on the price calculator. So this is a proper unit test. You can execute and write some code, and the code will look like this. You obviously get the repository and the converter in the constructor. Call the method to get the product and convert the price. Return the converted price also. There might be other cases we want to cover here. So that calculator should throw an exception if the product is out of stock. So we create an out of stock product. Again, stop the repository and say, whenever you get this ID, return the product. Create a dummy of a currency converter. It's not going to be used. We don't need to state any expectations on them. And call the price calculator again. Again, here there's no assertions here. Assertion is the actual expected exception. We expect that during execution of this method, an exception is called. Okay. So we actually defined the one by UUID method twice to implement this. And obviously, the implementation is quite simple. We just add a condition, test pass. So what we've done here, this is how we started. And we moved the price calculator to the unit testing world. Okay. We now covered it by unit tests. We still need some implementations. We need this doesn't work on its own. We only got interfaces for the repository and the currency converter. So we need to provide some kind of implementation so you can implement that interface in Doctrine and then internally use Entity Manager to put stuff into, to fetch stuff on the database. And similarly, some kind of a Guzzle currency converter that's going to use Guzzle to connect to the third-party API. Okay. And now, notice that what we've done in the unit test, if we talk about the product repository, we stated some expectations. If I give you a string, you return me a product. This is by no means supported in the implementation. We actually need to verify if any expectations we've done regarding the interface in the implementation. So we actually need to write an integration test for that repository. Integration test that will actually set up the database with fixtures or whatever you like, instantiate the repository with the actual instance of Doctrine Entity Manager. You can either create it on your own here or use the kernel test case and fetch it from the container. We'll use the same instance as your application does. Perform the action and verify, okay, if I'm pass a valid UUID, it's going to actually return something. So with this test, you actually verify the contract, and the interface is the contract. And on one side, you made some expectations regarding that. And on the other side, you need to actually verify if the implementation behaves how you assumed it behaves. Advantage of doing this in this way is you'll state expectations in more than one unit test. You'll be saying that all over again if that's one of your main repositories. If you ask for this product UUID, it returns an instance of a product, and you do that in more than one test. But those will be unit tests. They'll be fast. And you only have to test these assumptions once in integration test here, just to support those assumptions. Another test, okay, it really throws an exception if the product is not found. Those were two assumptions we made in the unit test. Okay, so there are two sides of the contract. The contract as an interface. One side makes assumptions, makes some expectations for the interface. And then the other side needs to verify that that implementation is worthy of saying, I really implemented the interface. That's more like answering the question, on the one side, do I ask the right questions? On the other side, do I answer them correctly? So for each expectation in the unit test, we should have at least one confirmation of that expectation in some kind of integration test. We don't have to stop there, because I didn't present the Guzzle currency converter, but you can imagine there's quite a lot of logic there that might still be extracted. So you can continue. It doesn't have to be one level. There's actually going to be multi-layered cake. So you might say, okay, currency converter doesn't use Guzzle directly. It will use some kind of the Acme API. That's the provider of the API to convert. We obviously need the implementation of that, and also the implementation of the API. That's eventually going to use Guzzle. So we're pulling it from the infrastructure, from the integration layer, and push it to the unit testing level. So we can write, for the Acme API currency converter, we can write a unit test. Set up the environment, stop the API, our newly introduced interface, call it, and assert that whatever. This is actually the case where the original price should be created, no operation should be performed. We might actually state that expectation on the Acme API, make it a mock and say, Acme API convert should not be called. Because the requested currency is the same as the target currency. And the other case for conversion, we set it up, we say whenever you ask for this, return 277, and make the call verify that you actually return to 77. So the implementation, I don't have the implementation of the unit test, but then on the other side, you need to verify the contract. You made some assumptions about the API, so you actually need to write an integration test for that. That's going to use the actual guzzle and make the API call to make sure that we talk to the API the way we thought we talk. And the simple test to verify that. This is the actual implementation. It's not relevant, it's incomplete, there's no exception handling. You can imagine you can actually continue doing this until you have a bare minimum on the integration level. Probably HTTP client left. You could extract logic related to the serialization of the response, building proper objects, and also abstract the HTTP client itself. I'm not going to do this. I think you should get the idea. So what we've done now is we move this up and extracted some stuff from the Gaussian currency converter up to the unit testing level. So we have even less need for integration testing. And if you look at it from a bit different perspective, if you put that in a circle, so that's all the stuff we unit tested. And start adding that gray or violet boundary is where you put your integration tests. So you say document repository, that's your your connection to the outside world. Inside you've got your own stuff that's unit tested, and on the boundaries you put the things that are integration tested. So you need to integration test document product repositories to be sure that it talks to document the way you think it talks. The same from the guzzle. And if you're familiar with the hexagonal architecture or ports and adapters, clean code, clean architecture from Uncle Bob, this is exactly what you end up with. By starting with proper unit testing, forgetting about the implementation details, you kind of push third-party stuff outside. And then you can start providing alternative implementation. Like for the repository, you could add in-memory repository. Perfect for acceptance tests. Your acceptance tests don't always have to go end-to-end, don't have to go to the database. It's fine if that just goes to the memory database or just a collection. You can provide a Symfony controller for that service, or it could be a Symfony console command. Your BHAT tests might use the same thing. So you start replacing those. I'm sure if you noticed that, but Symfony is not central to the switch. Symfony is a plugin to your code. It's kind of optional even. So don't start with Symfony, start with your code. What's really important, what's the core of your business. And that's it. Hopefully I didn't disappoint you by, I didn't give you any great ideas on what to use, what tools to use to make your tests faster. But I really believe that approaching the unit testing properly is going to make your tests pretty fast. Thank you. Do you have any questions? Don't see any hands, so I guess. Oh, yep. I can repeat the question if you.
So, the project that I'm working on is really based around user experience and how the front end is available, and that everything, when you click something, that it returns whatever you expect it to return. But the back end logic is like really simple. So it's basically you get an entity, you fill it up with data, you save it to the back.
Yeah.
So there is not really a need of unit testing, I think, because basically the controller is empty, it sends it to a service that fills up the entity, saves it to the database, and that's it.
So basically a CRUD application.
It's a really easy CRUD application, but the front end is really difficult or has complexity. And so we use Behat. But since you were talking about those things, like you have pop-ups, you have to wait for them because otherwise they don't work and so on. And how would you recommend testing something like that?
So I'm not even sure if I would test the backend. You can probably generate it if it's that simple. And for front-end, I would just use JavaScript tools, front-end tools. And properly decouple from these are basically two separate applications. So you should test them separately and then integration test them together just to make sure that, okay, they more or less talk to each other. But you don't have to do that for every possible scenario. Every possible scenario should be tested in JavaScript. The same rules apply on the JavaScript side. It should be properly unit tested, some amount of integration tests, and then end-to-end tests, but really few of them, just to make sure that the front end talks to the back end properly. Everything is wired up together. Helps. Okay, I'll be here till the end of the day, so if you can, if you want to chat with me, just do. Thank you again.